In this video, we're going to look at precipitation. And precipitation happens if you have an ion in solution and you're over the solubility of that ion or that ionic compound, then they will form a solid due to equilibrium and fall out of solution. And this idea is the same idea we've been talking about this class, where we talk about equilibrium and we're talking about K and Q again. So this isn't anything new here. So let's say you're dissolving an ionic compound. It will have an equilibrium constant KSP. And if your Q is equal to your KSP, then you are in a saturated solution and you should get no solid reforming. If your Q is less than your KSP, well, that means you're below saturation, you're unsaturated, and you could dissolve more solid in your solution. If your Q is greater than KSP, then you will precipitate solution out. You have too many dissolved ions in there, so they will reform the solid because of equilibrium. However, for ionic compounds, as we talked about earlier in this class, you can get Q greater than K without any solid being formed. That's called a supersaturated solution. These solutions are very unstable, and any piece of dust or any vibration that will enter the solution will cause spontaneous precipitation. But it is possible to get supersaturated. It is possible to have Q greater than K without any solid being formed. Now, let's say you have a solution that has many ions in it. They're all dissolved, and you want to know what ions are in that solution. Well, we can use a procedure called selective precipitation to figure that out. Selective precipitation, the idea is you add a reagent, and that reagent will make an insoluble solid with the ions that are dissolved. And so it will take that reagent or that compound that was previously dissolved, make it an insoluble compound, and take it out of solution. And any reagent can react with more than one cation. As long as the KSPs are different, you'll see this selective reaction. So what I mean by that is, let's say you have multiple ions in solution. You add a reagent that interacts with these three ions. Well, it will react with whatever has the smallest KSP first and form a solid. Then it'll react with the second one and the third one as well. But usually it will be the smallest KSP that it will react with first. Now we can determine a scheme to or we can make a scheme to determine what ions are in our solution. And we can go through this scientifically. This is called quantitative analysis. So let's say that we have a test tube full of different cations. If they're all dissolved, how do we figure it out? That is what qualitative analysis is. And it's all in the lab. It's lab work. And this is actually done all the time, especially when you get your report of what's in your water. They can use a scheme similar to this. So you have several ions, and what you do is you just add different reagents to make solids out of these cations. So you're going to form an insoluble solid. You remove that insoluble solid, and you keep doing it till all your ions are removed. And the idea is usually you want one of the ions to precipitate out. And scientists have actually developed a scheme to do this. So here we have 5 different classes of cations, and they're all different colors because they'll all interact with different reagents. So let's say you were given a test tube just full of this, and you're told remove all the ions from solution. So the first thing you could do is add hydrochloric acid. Your silver, mercury, and lead will form insoluble chlorides, and they will fall out of solution. And then everything else will be dissolved. Then you can add H2S. All of the red cations here will form insoluble sulfides, and everything else will be left in solution. Then you add a hydroxide. You'll form insoluble sulfides and hydroxides now. Some of these sulfides, they did not precipitate out in group 2 because they are soluble at a pH of 7. Adding this OH, you lower the pH, and so now these are insoluble. And then you can add phosphates to make insoluble phosphates, and after that you're left with 3 cations: sodium, potassium, and ammonia. If you want to know, let's say that you only have one of these group 5 metals in solution, and you're tasked to figure out after all of this which one of these metals remain in solution. What you would do is that you would remove all the water, and then you would burn the salt, or the metal rather, and you would see what's left in solution. Based on what color of flame you get, you will be able to tell what cation you have. That's called a flame test. And this is quantitative analysis on a big scale. And that's all for this video. I will see you in the next video.